armatures have a few more spaces than other objects in Blender. All of these spaces are just coordinate systems that have different reference points. I'll do my best to explain them all in this lesson, but if you don't quite follow along with all the different spaces, do not stress too much. The two main ones that you'll need to know are just world space and local space. The rest will most likely make sense to you later down the track. I really found it confusing when I was learning this. At first I thought I understood it, then I realized I didn't understand it at all, and then one day it just suddenly clicked. They're all just coordinate systems with different reference points. Now, I've said that twice for a reason. That's the thing I really want to sink in. They're all just coordinate systems with different reference points. I wish someone had said that to me 3 times when I was learning. It definitely would have helped. Now, before I jump into explaining things, for simplicity of these examples, I'm only going to be talking about the location because I think this is the easiest thing to understand. But everything that I explain is also applicable to rotations and scales as well. All right, let's get started. World space, which is also called global space, is the coordinate system relative to the origin of the scene. Now, the origin of our scene is down here where all of our 3 axes meet. That's the X, the Y, and the Z. So the world space of our monkey here is 1, 2, 3 in the positive X, and then 1, 2, 3 in the positive Z. We can see that represented up here in the location of our monkey. It has a world space of 3, 0, 3. And world space calculations include everything that puts it in this actual location. That means parenting, that means constraints and drivers. Whatever puts it in this position gets included in world space. And just to demonstrate this a little bit further, I have this random armature here, which is parented to the monkey. You can see up here that it is 3 spaces to the right, 1, 2, 3, from its parent. So it thinks its local space is 3, 0, 0. However, this is not where it is in world space. We can count the units, 1, 2, 3, 4, 5, 6. That's 6 in the positive X, and 1, 2, 3. 3 in the positive Z. Its local space is 3, 0, 0, but its world space is 6, 0, 3. I like to think about world space as being where you see it in the world is what you get. Or whiz-a-wig gig 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 gig. Yep, pretty sure I got that right. Local space with parent is a space type that is only available for bones or armatures. And that's because bones work a little bit differently to other objects. Bones have edit mode and they have pose mode. And so the bone transformations in pose mode are actually evaluated relative to its rest position. That is where the bone started in edit mode. So here in my example, I'm in pose mode, and if I jump into edit mode, you can see that these bones are in the same place. So it has a local space of 0, 0, 0, even though its parent is over here. So if I move this 1 space to the right, we have a local space of 1, 0, 0. Just to make it a little bit easier to visualize what's going on, I've just added another bone here as a marker. This is just a visual reminder of where the bone was. Now, local with parent actually includes the changes made along the parent hierarchy. So if I move the direct parent up, local with parent is actually relative to this position here. That is 1 space to the right and then 1 space up. And this space type doesn't actually matter if you move the direct parent or anywhere along the parenting hierarchy. Here is the grandparent. If I move this up 1 more space, it's now 1 space in the X and then 2 spaces in the local Y axis. Now you also need to know that this space type also includes any transformations that may occur through constraints and drivers as well. But it is relative from its current position to its rest position. When dealing with objects, local space is always relative to the parent. And if that object doesn't happen to have a parent, you can think about it as being parented to the world. This monkey head here doesn't have a parent. It is 3 spaces to the right, 1, 2, 3, and then 3 spaces up. So its local space happens to be exactly the same as world space. However, our armature object over here is parented to that monkey head. So its local space is relative to the origin point of the monkey. That would be 1, 2, 3 spaces in the positive X, which is 3, 0, 0. If I rotate the parent, the local space of the armature hasn't changed, even though it has moved in world space. And that's because it's still relative to the X-axis of the monkey head. Its local space is still 3, 0, 0. When you're dealing with bones, local space is relative to the parent here. I have this child that is parented to this bone called parent, but there is one key difference with bones, and that is that its 0, 0, 0 position, or its starting position, is always offset. so that's actually located at its rest position. If I jump into pose mode, it's in the same position, so this is its local 0, 0, 0. If I move this bone in pose mode one space along its local x-axis, it's measuring that movement relative to where it was in its rest position. Now, local space calculations also include any constraints or drivers that change this bone. However, the one key difference with this version of local space is that it's going to ignore any of the transformations that happen to any of the parents. If the parent moves, it's not going to affect this plain local space version like it did with our with parent option. So to summarize, local space includes its own transformations. It also includes transformations from constraints and drivers, but it does not include any parent transformations. One other flavor of local space that is only available for bones is local space owner orientation, and that's got to do with constraints. So here I've got a setup where we have a constraint on this owner bone. It's going to copy our target down here, and the default local space behavior is when I move the target on its local y-axis, the owner is going to move on its local y-axis. If I change this over to local space owner orientation, and then I try this again, you'll notice that it's going to move in the same direction. That is only available under the target. You'll see it's not here under the owner, but it is a super handy option that we will utilize quite a lot when we're rigging. Now, pose space is another space that's only applicable to armatures, and that's where the bones are actually evaluated at the armature's object level. Here we have an armature, and its origin point happens to be at the world origin point. So that means technically pose space and world space would be the same in this situation, but I'll change that in just a moment. So the pose space position for this bone here would be one space to the right, or positive X, and then one space up on the Z. And that's where it is in world space as well. But if I move this one space to the right, pose space is still exactly the same because it hasn't moved relative to the object origin, except it is now two spaces on the global X. So that's why I think about pose space as being object space. It's relative to the object origin. The final space I want to talk about is transform space. This one's only available for bones, and more specifically, the drivers on bones. Here you can see me just add a driver, and you'll see that we have this transform space option here. So what is transform space? You can think about transform space as being these raw input values here. If you physically change these in the input boxes, that's what it's going to use. That is transform space. Now that you understand a little bit about space, I hope that it no longer frightens you. As I said earlier, all you need to know for now is local space and world space. And in fact, the only ones that you're going to use for a very long time will be world space and local space, and possibly local space with owner orientation. And thankfully, those spaces are really easy to understand. But if you don't understand everything now, do not worry. You do not need to understand everything right now. One day, it's just going to click. They're all just coordinate systems with different reference points.